We're going to finish up this chapter now by talking about how to produce, transmit, and decode radio waves. We're going to starting off with a sound, digitizing it, turning it into a radio wave, receiving the radio wave, and then turning it back into a sound. This is a really fun video, so I hope you enjoy this one. All right, so we're going to start off by creating a sound. So say someone is singing into a microphone. Well, the microphone, which has a capacitor in there, it has a little diaphragm in there, and the diaphragm vibrates, produces an electrical signal that is then sent to an audio frequency amplifier. AF means audio frequency. Okay, so this audio frequency is amplified and sent to a mixer where it is combined with a radio frequency. The two of them combine together and you get your modulated signal, your radio wave, which is then amplified and sent to an antenna, and the antenna produces electric and magnetic fields just like we saw earlier in the chapter. All right, before I go any further, let me talk a little bit about this mixing process here. You're going to have an audio frequency, you're going to have a carrier frequency also, or your radio frequency. And the way they are combined varies on the frequency that you're using. The first method we're going to look at is where you have your audio wave, and you're going to mix that signal with your carrier wave, and you just straight up add them together, and you get your carrier wave, which is changing in amplitude as it progresses through space. So this is called amplitude modulation, amplitude modification. Sorry, amplitude modulation. There it is. So this is called amplitude modulation, or AM radio. It is done completely by taking the carrier frequency and adjusting its amplitude so that its amplitude matches your audio frequency. The second method that we use is where we take the audio signal and the carrier signal, and then whenever you have a high amplitude for the audio signal, that will just slightly increase the frequency of your carrier wave. And when you have a large negative amplitude in your audio, that will decrease the frequency of your carrier wave. So you have a high frequency, low frequency, high frequency, low frequency, high frequency, and the variations in the frequency match your audio wave. So this is what we call frequency modulation, or FM radio. Okay, so when we come back here, we've created a sound. It's got a sound wave, and we've got a carrier wave. They are mixed either AM or FM methods. And then that new signal is amplified again, sent through an antenna, propagates all the way through space where it reaches your antenna. Well, your antenna is then going to vibrate. It's going to be receiving all sorts of frequencies from many, many different radio signals. And it's going to create circuits in this little path right here. But we can use this tuning circuit to only oscillate at a given frequency. So for example, you're getting all sorts of radio waves here, but if you want to listen to 95.7, whatever that station is, I don't listen to 95.7, so don't judge me. If you want to listen to 95.7, then this is set so that it will only oscillate at the frequency that that 95.7 has. So it picks up the FM radio band at 95.7 megahertz. And then once you select only the one signal that you want, the signal that you receive is then amplified, and then you get to a demodulator. Since you know what frequency you received it at, you just subtract that frequency out. You take the radio frequency back out of the equation. The only thing left is your audio signal. You amplify your audio signal, send it through a loudspeaker, and you have your radio waves. Kind of a fun learning of how it is that you can hear in your car what's being transmitted from miles and miles away.